we need to talk just a little bit about what's happening behind the scenes when actually they're shared in pairs. When a pair or two electrons are shared to form a covalent bond. And I thought maybe we'd pick on hydrogen. So we said hydrogen is one of those diatomic elements, and a hydrogen atom actually only has one electron, and its one electron is in the 1s subshell. You're like, oh, I didn't know I need to remember that. Well, yes, you do. And S-type subshells are spherical. So we could show that that electron orbital like this, where this is the nucleus with a proton and maybe a neutron, maybe not. That's the nucleus, and this actually is the electron cloud. Okay, now that is a hydrogen atom. So it actually joins with another hydrogen atom. So I'm going to draw the nucleus of another hydrogen atom. Now, in order to form this, I'll go ahead and draw H, chemical bond H. In order to form that chemical bond, what has to happen is what we call an overlap of the atomic orbitals. So this, maybe I'll draw a different color. This actually is the second hydrogen atom. And can you see this overlap right here? This overlap actually is where electrons are shared. Okay, so this overlap is where the electrons are shared. I'll go ahead and do a, I don't know if this should work. I'll do a green dot for one electron and an X for the other electron, and that actually is the region where electrons are shared. That is that chemical bond right there. So it's an overlap of original atomic orbitals, okay, that is where a region of space where electrons hang out and form that chemical bond. Okay, so that is now called a bond orbital. This is a bond orbital. It's a chemical bond orbital. It's a covalent chemical bond orbital. Okay, oh my goodness. Okay, so bond orbitals, like you saw a minute ago with hydrogen, H2, bond orbitals will always have two electrons, and we talked about this earlier in atomic orbitals, that bond orbitals with those two electrons need to have opposite spins. That works for me, one going up and one going down, right? And the other thing we saw actually an example of H2 is that the electrons can come from different atoms, which they did, or the electrons actually can come from the same atom to form that covalent bond. And we'll be seeing that more when we draw more structures of compounds where electrons are shared.